reduction formula. And this is a method for integrations. And it's a topic, it could cover. I remember I taught this topic about a week. So here I just take 3 examples, just serving as an introduction or a review. You can go touch all sorts of material about this topic. Now here I just take 3 examples. The first example is tangent nth power of x. I call this one In. In is integral tangent nth power of x dx. Then I split this tangent n into tan n minus 2 of x multiplied by tangent square, right? Tangent square is secant square minus 1. So it will have 2 integrals. The first one is tangent n minus 2x times secant square x dx. The other one is integral tangent square minus 2x dx. No, 1 dx. Okay, this one is equal to tangent n minus 2x. This is d tangent x, right? This one, this is In, this would be I sub n minus 2. Huh? Okay, so this one, finally I get n minus 1 tangent n minus 1 of x. That is this one integral, and minus n sub minus 2 here plus c. Okay, that is not the answer, not the result for this integral, but rather I get formula. Instead of integrating this, but I got a formula for this integral in which the power of tangent has been reduced. That is called reduction formula, right? Instead of getting the result, I got formula in which the power has been reduced. That is the story of reduction formula. Now, in which I get 2 things. I1 is equal to tangent, right, x dx, which is equal to log secant, secant x plus c. Okay? And I0 is equal to 1 dx. Right? So this is equal to x plus c. Now, then I can do, say, example, say, how about tangent fifth x dx? Then this one is equal to, according to the formula, it will be 4, and tangent fourth of x minus, this is I3. I3 is equal to 2 tangent square x, right? Minus I1. Minus become plus, right? Plus I1. I1 is natural log secant 10x. So that has been done. Yeah. Yeah. Okay, now how about tangent eighth? Tangent eighth is equal to, according to the formula, it would be 7 tangent 7x, right? Minus, this will be tangent fifth. Tangent fifth would be, yeah, tangent 7 fifth. Yeah, this is 5. Then plus tangent 3. Then tangent 1. And tangent 0. So plus x plus. You see, that is a tangent eighth. So I can have a whatever in the natural number for tangent. That's called reduction formula. Okay. Now this is one example. Now let me take another example. How about definite integral from 0 to half pi cosine n x dx. I call this one is in, right? Well, in which that I0 will be x plus c, right? Plus c. Let me forget a c. I1 will be cosine. Cosine is sine 0 to pi. I forget the boundary. So this one is equal to 1, right? Yeah. This is from 0 to half pi. So this one equals to half pi. Okay, this is I0. This is I1. Now, for this, I do that, right? This is a cosine n minus 2 x times cosine square times cosine. Sorry, I should do 1 and not 2. N minus 1 times cosine. The other cosine is the derivative of sine. Okay. Yeah, then I can do by parts. UdV, right? Cosine n minus 1x sine x from 0 to half pi minus VDU. V is this, right? Sine x. Du, it is n minus 1 cosine n minus 2 times the derivative of the cosine, which is negative sine x. I change this to plus, right? Negative. So this one is equal to, this is 1. Cosine half pi is 0. This is 0 is 0, right? Okay. Plus n minus 1 integral. This is cosine n minus 2x times sine square. Sine square is 1 minus cosine square. Okay, this one is equal to n minus 1. This time this one is what? This one is I n minus 2, right? Minus this one time this one is cosine n. So this is I n. Yeah. Then move this over there. Yeah, I get then In is equal to, this is 1 In, right? This is N, and N is equal to N minus 1 over N minus 2. Okay, so I get the formula. Well, how about example of I8 is the cosine 8th x dx from 0 to half pi. Now, instead of integrating, I'm using the formula. Okay, so this one is equal to, the formula is 8 here, 7 here, times I6. I6 is 5 over 6 times I4. So times 3 over 4. Then times I3. I3 is 1 over 2 times I0. Yeah, oh. Yeah, so this one is equal to, yeah, this one is equal to 35 over 256 pi. Okay, so that is very good, really good. Well, of course you can do whatever the n is. See? Okay, that is a second example. Now, the last example for today's video is integral xn to the e to the power of x dx. So I take one example, which is a non-trig function. While I'm using by parts, right? This one is equal to xn d e to the x. So I can use by parts, which is equal to u v minus v du. V du is x minus 1 dx. So this one is equal to x to the n ax minus n. This is a n minus 1. N minus 1. So that is the reduction formula. Okay. Well, I need I0, right? I0 is equal to e to the x dx, which is equal to e to the x plus c. Okay, when you use the reduction formula, it must have an end. The end is I0. So just, for example, how about I6? This is equal to x6 e to the x dx, right? Instead of integrating, I'm using the formula, which is equal to uh, which is equal to the formula, the x6 e to the x, right, minus 6 I5. So this one equal to x to the 6 e to the x minus 6. The 6 times x5, right? X5 will be x to the 5 e to the x minus 5 to the I4. And just, just continue x6 e to the x minus 6x5 e to the x plus 30 I4. I4 is what? I4 is x fourth e to the x minus uh, minus then it's 120x 3x e to the x, and the continuous plus 360 and the ex square ex minus 2 I1. Well, yeah, and I1 I can continue. This was equal to, well, x6 e to the x 6 x5 e to the x plus 30 x minus 120x plus 360 x squared e to the x minus 720 times x e to the x and plus 720 I0. Wow. Yeah. Okay. So everything now I0 is what? I0 is e to the x. So I have a to the x common factor. So then equal to x6 minus 6x5 plus 30x4 minus 120x3 plus 36x squared minus 720x plus 720. Wow, plus, yeah. That is well, I may have some errors, but it's not important. See, the method here I introduced is important, okay? Because there's lots of tedious calculations, but this is not important actually. See, the most important is that how to get a formula. Okay. Well, I hope you like it. Thank you.